Okay, let's have a look at this problem. It says OPQL is a parallelogram. First thing I'm going to do is actually draw this for myself. Okay, so that's P, that's Q, that's O, L, there's T over there. And it says OP is R, all right? And then OL is S. Those are represented by the vectors R and S, all right? But it says that it's a parallelogram. And what does that mean? What's a parallelogram? Well, a parallelogram is a special type of quadrilateral where the opposite sides are equal in length. That's what those symbols mean. So these two sides have equal length. These two sides have equal length. And the opposite sides are also parallel to each other. So this means that the opposite sides can also be represented by the same vector. So notice what I'm doing. I'm not even interested in what they're going to ask. I am just using my knowledge of parallelogram and vectors to put more information on the diagram. But what is a vector? A vector is a quantity that has both magnitude, which means length, and direction, which means going one way or the other in space. It has a very specific direction. So OP, this vector OP goes from O to P. That's the direction it goes, and it's represented by R. And LQ is also represented by R because it is parallel to OP and of the same length or magnitude. Okay, so we could write also that if OP is equal to R, then L to Q is equal to R. So if OP here is equal to R, then LQ here is equal to R. We can also write if OL is equal to S, then PQ is also equal to S. Because they're going in the same direction and they have the same length, same magnitude, going in the same direction. All right, what else do we got? It says here that the point T is the point such that PQ is equal to QT. So then let's make this a little bit longer. T. Then QT is also equal to S. Okay, what else do we got? We're told that the point M divides PL in the ratio 2 to 1. So M divides PL in the ratio So P to M, PM to ML will have the ratio 2 to 1. Like you have PM and L here. So that's 2 to 1. Where that is M right there. All right. But what does that mean? Can we represent that in another way? Yeah, we can say that PM, this distance here, PM, over the entire distance of PL would be equal to this 2, and the total here would be 3, because it's divided into 3 parts. So this would be 2 over 3. So that, and then if we multiply both sides by PL, we put that in blue right here, multiply both sides by PL. PL cancels, and then we have PM is equal to 2/3 PL. Does that make sense that PM here is 2/3 of PL? Yeah, that's about right. All right. So now we've taken everything that they have told us in this question and put it on the diagram. Now we can actually answer the question. They want us to find PL, vector PL, going from P to L in terms of R and S. Well, how can we get from P to L? Well, we can go this way, but we don't have any vectors. I mean, that's the job, to find a way to describe PL in terms of R and S. Well, I can start here at P, then I can go down to O, then I can go over to L. That can be the path I can take, and therefore I can use these vectors to describe how I get from P to L. So how do I do that? Well, first I say PL is going to be equal to PO, that's here, plus OL. All right. Now what is PO? But if OP is equal to R, then PO is equal to minus R, because it's going in the opposite direction. Same length, but going in an opposite direction becomes a negative vector. That's it. So PL will be equal to PO plus OL, but PO is going to be minus R, and then OL, that's S. We can rewrite it as S and a minus R there. And that's our answer for PL. Then, what do they want next? They want us to find OM. OM. What's that? That's going from here to here in terms of R and S. How do we do that? Well, we can go from O to P and then from P to M. So we write that OM is equal to O to P plus P to M. All right. O to P, we already know that is R. And P to M, do I have an expression for that? Let's see. PM, yeah. Over here we found that PM is 2/3 of PL. So we can write that. This PM here is 2/3 of PL. 2/3 of PL. And we have what PL is, right? We just found what that was. So 2/3 of this S minus R. Okay, we need to simplify this expression. So we have this 2/3 multiplied into here. So we have 2/3 S minus 2/3 R. And we have R over here, which is the same thing as 3/3 or 1 R. Cool. So we have 3/3 R minus 2/3 R plus 2/3 S. 3 minus 2 gives us 1/3 R plus 2/3 S. Okay, and now I can factor out 1/3, and I'm left with R here and 2S. Can test it. 1/3 times R gives me the 1/3 R. 1/3 times 2S gives me the 2/3 S. So that is what OM is. Next thing they want is us to prove that O, M, and T are collinear. What does that mean? Collinear means that O, M, and T can be said to lie on the same line. Something like this. O is here, M is here, T is here. They're all on the same line. Or in this case, O is there, M is there, and T is there. All right, but how do you do that? To prove that they're collinear, you would say that OM is a scalar multiple of OT. It's called scalar multiple because this K here is a scalar number. It's just a regular number, and it's multiplying against OT. Of course, it can be the other way around as well. You could have OT is some scalar multiple of OM. And that proves that they're collinear. All right. So let us define what OT is. OT would be going from O to P, P to Q, and then Q to T. So OT is OP plus PQ plus QT. Okay, and what is OP? OP is the same thing as R, PQ is the same thing as S, QT is the same thing as S. So that is R plus 2S. That's what OT is. But wait a minute, we know that OM, we found OM to be 1/3 of R plus 2S. Are we seeing a pattern here? Yes, we do. This means so that OM is a scalar multiple of OT. That's that 1/3 R plus 2S here. And OT, we already know is R plus 2S. So that scalar multiple is 1/3. Then we hit them with proven underline. Okie dokie.
Shout out to Cinnamon.
Shout out to Cinnamon.